everyone. Welcome to my YouTube channel Erudispace. I am Dr. Mohanty, and today we will discuss about the regenerative air cooling system. The regenerative air cooling system is actually a modification of the simple air cooling system. It has all the components of a simple air cooling system. Apart from that, it does have an additional component, which is your regenerative heat exchanger. So now we'll discuss the regenerative air cooling system, and also we'll discuss the different processes with the help of the TS diagram. So the different components of the system are your diffuser, your compressor, your combustion chamber, your gas turbine, your heat exchanger, which is in fact your first heat exchanger. Second one is your regenerative heat exchanger. You do have a cooling turbine and you do have a cooling air fan. Now we'll discuss how the system actually works. First, the ambient air is drawn through the diffuser. As it passes through the diffuser, its pressure is increased, and this type of compression is what we call your ram compression, and this type of compression takes place due to the shape of the diffuser, which is a smoothly varying section which converts the kinetic energy into pressure energy, but no work is spent in ram compression. Then this ram air is made to pass through a compressor. Compressor actually compresses the ram air further, and there is significant increase in its pressure and temperature. Out of the total compressed air, a major portion is taken to the combustion chamber. In the combustion chamber, heat and fuel is added to the compressed air, and then this is taken to the gas turbine, where it expands and does some mechanical work, which in fact runs the aircraft. A part of the power that is developed is used to run the compression. Then a fraction of the compressed air, which has not been sent to the combustion chamber, is then made to pass through the heat exchanger. A fraction of the ram air is also made to pass through the heat exchanger, which actually provides the desired cooling, because due to compression the temperature of the air drawn in would be significantly raised, and the temperature of the ram air will be lesser than the temperature of the air that is drawn from the compression. So due to this, the cooling of the air drawn from the compression will take place. After that, this air is made to pass through the second heat exchanger, which is your regenerative heat exchanger. And here, this is actually cooled by a fraction of the air coming from the cooling turbine. After being cooled in the regenerative heat exchanger, the air is made to pass through the cooling turbine. In the cooling turbine, the expansion of the air actually takes place, and due to this, the power that is developed is actually used to run the cooling air fan, which actually draws the air that is to be adjusted to the atmosphere from the heat exchanger. Then the air, after passing through the cooling turbine, a part of the air is used to provide cooling to the air that is entering the regenerative heat exchanger, and major portion of the air is actually sent to the cabin or cockpit. So after passing through two heat exchangers, that is the first heat exchanger and the regenerative heat exchanger, the temperature is significantly reduced. So as it enters the cabin or cockpit, it receives heat from the medium to be cooled, thereby producing the desired cooling effect. All the processes can be discussed with the help of a temperature entropy diagram. This actually shows a temperature entropy diagram, and four pressure conditions are shown. You do have ambient pressure, you do have cabin pressure, you do have ram pressure, and then you have the main compressor pressure. And these lines actually represent the different pressures. So first process is the ram compression, and that is taking place in the diffuser. 2-3 represents the compression that is taking place in the main compressor, and here some amount of work is spent upon the system for the compression to take place, and 3-4 actually represents the cooling of the air in the heat exchanger, that is the first heat exchanger, and 4-5 represents the cooling that is taking place in the regenerative heat exchanger. Here the air is pulled by part of the air bled from the cooling turbine. This is represented by 4-5. 5-6 actually represents the expansion that is taking place in the cooling turbine, and then 6-7 actually represents the refrigeration that is taking place in the cabin or cockpit. Both the compression processes as well as the expansion processes are shown to be isentropic processes. But if you consider the effect of irreversibilities, all these processes do take place with some increase in entropy. So in that case, 2 will become 2 dash, 3 will become 3 dash, similarly 6 will become 6 dash, because the compression as well as the expansion processes will take place with some increase in entropy. Next thing that we will find out, the coefficient of performance or the COP of the refrigeration system. So COP of any refrigeration system is the ratio between the refrigerating effect divided by the work done in the compression. So here 6-7 represents the refrigeration process, and 2-3 represents the compression process, because already I have told you that 1-2 is your ram compression, and here we do not require to do any work to compress the air. So in this case there will be difference between the mass when we are considering the refrigerating effect and when we are considering the work done. The refrigerating effect will be equal to the mass of air that is entering, let it be M1, multiplied by specific heat at constant pressure, multiplied by the temperature difference, which is in fact your T7 minus T6. But this is not the air that is bled up from the compression, because the air that is bled from the compressor will be different, that will be higher, because part of the air coming from the cooling turbine is used in the heat exchanger. So if you consider that, then the work done will be M2 multiplied by Cp into T3 minus T2, because here M2 represents the mass of air that is bled from the main compressor, and this value of M2 will be higher than that of M1, because part of the air is used for this regenerative heat exchanger, that is used to cool the air in the regenerative heat exchanger. Now the COP will be the ratio between M1 multiplied by T7 minus T6 divided by M2 into T3 minus T2. So I sincerely believe that today's lecture on regenerative air cooling system would be extremely useful in understanding the concept of regenerative air cooling system. If you have any doubt related to this lecture, please do put questions so that I will try to answer. I would request you to subscribe to my YouTube channel Erudispace if you have not done so till now. I would further request you to share this video with your friends and relatives to improve its visibility. Thank you very much for watching this video. Hope to see you soon for another lecture on my YouTube channel Erudispace.